Hey everyone, in this video we are going to solve one more LeetCode question, and it's question number 1464, maximum product of two elements in an array. This is an easy level question and it has been asked by, let's see, what are companies? Okay, so this has been asked by Amazon, Cisco, Samsung. So let's see how we can solve this question and what this question is all about. So in this question, we are given an array of integers nums and we have to choose two different indices, that is I and j of that array, and we have to return the maximum value of this calculation. So the few things that we understood by this statement is, firstly, we need two indices. Secondly, we have to return a maximum value that we can calculate using these two indices, right? So this is the nums and this is the output, which has been calculated by I and j when I was 1 and j was 2, and these two are nothing, it's just 4 and 5 of this array, and the calculation resulted into 12, which is the maximum value we can obtain. So the first and the foremost approach that I can think of is iterating through this array and checking for all the possible combinations of I and j, right? This will be our brute force approach. So let's try to understand how we can solve this question using this example, where the nums array is given as such and the output is 28. So the first approach that I can think of is checking for all the possible combinations of I and j, right? So if I am saying I'll be traversing this array, then my I can be this, j can be this, or I can be this, or j can be this. And in this manner, I have to check for all the combinations, right? So for that, what I can do is I can run two loops, and one for I and one for j, and then I can check that formula nums I minus nums j and calculate the value. So if I'll see here, 28 is being obtained by 5 and 8, right? That is 5 minus 1 into 8 minus 1, 4 into 7. So if I'm going to solve this question using this approach, what will be the time complexity? In this case, the time complexity is going to be around, I guess, is going to be around big O of n square, right? In worst case scenario, how we got this n square is, if my I is 1, then for I equivalent to 1, I'm checking for j n minus 1 values, right? Where n is the length of array. So for 1 I am checking n minus 1, and if my I value is 2, then I'm checking j for n minus 2 values, because I'll be shifting my I as well while traversing this array. So if my I is at here, so my j will start from here. That's why for I equivalent to 1, I'll be checking j n minus 2 values. So if I'm going to check this j series, where j is one plus 2 plus 3 plus 4 up to n, this is partial sum series, and this series summation is equivalent to n into n plus 1 by 2. So this is the summation of this series. If we are going to resolve this, it will become n square plus n by 2, and we know that n square is the dominant one, so the time complexity is n square for this approach, and the space complexity will be big O of 1. So is there any other approach with which we can solve this question? So yes. So with first approach, we got our time complexity as big O of n square. And let's see what this second approach time complexity will be. So the second approach for this question will be, we know that we want to obtain maximum value, right? We want maximum value. So in order to obtain maximum value, we need only maximum elements, right? So firstly, maximum element in this array is 8 and second maximum element is 5. So our focus should be only the two biggest elements present in the array. So what will be the easiest way of fetching the two biggest or the greatest elements from an array? We can simply sort this array, right? We will sort this array and it will become 2, 2, 3, 4, 5, 8. And once we have sorted this array, what we can do is we can take the last two elements and we can simply return 5 minus 1 into 8 minus 1, and this will be our result. So the time complexity of this approach will be big O of n log n. N log n because we are sorting this array, and after sorting we are doing nothing. We are simply taking the last two values and returning the product in this way. So the time complexity of this approach is n log n, which is better than the first approach, but space complexity of this approach can be big O of log n or big O of n. Why? Because the sorting function that we'll be using in Python, at least that sort function, this is being implemented using timsort in Python, and timsort uses big O of n space complexity in worst case scenario. So that's why we are considering big O of n as space complexity, but I'm saying log n as well because if you are using Java or C++, in that case the inbuilt sort function are built on quick sort, selection sort, and combination of all these things in C++. So the space complexity in these two languages, it can be log n in worst case scenario. So for that reason I told that space complexity can be this or this. Timsort algorithm, I'll be coming up with that full video on timsort algorithm soon, but for now we can consider that in worst case scenario this algorithm uses big O of n space complexity, and that's the reason the space complexity of this approach is big O of n. So this was the second approach in which the time complexity was better than the first one, and space complexity was big O of n. So can we optimize it further? So yes, we can. We can eliminate this sorting mechanism and we can solve it using different approaches. So let me just clean this board and we'll see the third. So let's see the third approach. So in third approach, as I already told that we'll be eliminating the sorting mechanism. So what we'll be doing is we'll be keeping a check of biggest and second biggest value. So what we can do is we can define two variables, biggest and second biggest, right? We can now initialize them as 0 for now. Let's traverse this array, and what I'm saying is this value is greater than biggest. So if this value is greater than biggest, in that case firstly update the second biggest, which will become equivalent to biggest, and then update biggest with this number, that is 3. So now my second biggest becomes 0 and my biggest becomes 3. Then I will go to next element. I will again check the same thing. Is this element is greater than biggest? So yes, it is. Then again I will do the same thing. I will update firstly my second biggest. It will become 3. Then biggest will become 4. Then I will again go to next element. Is this greater than the biggest? Yes. So again the same thing. And I will go to this place. This will again same thing, 5, and biggest will be 8, and then I will go to this place where this is 2. So now I can see my biggest is not less than this element, right? But there might be a possibility then rather than 2 we are having 6 over here. In that case what will happen, we won't update our biggest, but we really need to update our second biggest because 6 is greater than 5. right? So in that case, we will check the maximum of existing second biggest and the value at which we are currently present. So I'm saying greater than, take max of 6 or 5 for second biggest. So in this case, it will become 6. And at last, we know that we have traversed this whole array. So now what we will do the same thing. Biggest minus 1 into second biggest minus 1, and we will return its value. So this was the third approach, in which we simply used two variables, traversed this array, and returned the answer. So this was the even more optimized approach than the second one. So in this, we hadn't sorted our array, so time complexity will be around big O of n, because we'll be traversing this whole array, and space complexity is again big O of 1. We are not using any extra space, so it is 1. We are using only two variables. So this was the third and the most optimized approach. So now let's code this whole solution. I am not going to code the first two approaches, but I'll be showing the code for the third approach in two programming languages, that is Python and Ruby. So if you want to try out the first two approaches code, you can try it on your own. So let's now check the coding part. Firstly, we are going to code this whole solution in Python, and afterwards we'll be doing it in Ruby. So as we already discussed, firstly we want two variables, that is first biggest and second, initializing them as 0. After this, for num in nums, I'll be checking if this num is greater than biggest. In that case, firstly update the second biggest, which will become equivalent to biggest, and then update our biggest with this num. And if this is not the case, then check if this value is greater than the second biggest, right? And lastly, return biggest minus 1 into second biggest minus 1. Let's see if it works. Okay, try to submit it. So you can see that this has been accepted. Now let's code Ruby solution. So in Ruby as well, we are going to do the same thing. Firstly, biggest is 0, then second biggest is also 0. After that, we'll be running our loop, which is like nums.each. So for each element in array, we are saying do I, where I will be the representation. So inside this, what we were doing, we were checking if this I, or let's name it as num, because in Python code we used it as num, right? So here as well we'll do the same. If num is greater than biggest, in that case, inside this if, what we were doing, we were firstly updating our second biggest. Second biggest was getting updated with biggest value, and then biggest value was getting updated with num value. And the else of this if will be second biggest equivalent to second biggest comma num dot max. So this dot max will work similar to the max function in Python, and after getting out of this loop, we'll be returning biggest minus 1 into second biggest minus 1. That's it. Let's see if I hadn't made any typo, which I don't think so. Let's try to submit it. Okay, so yeah, you can see this is also accepted. I hope this video was helpful for you all, and if you really find it helpful, then you can like my video, subscribe my channel, and I will soon come up with more such questions. And Till then, take care, keep messing with algorithms, and thanks for watching.